Welcome to our Azure Incident Retrospective. I'm David Steele.
I'm Sami Kuba. We work in the Azure Communications team.
In addition to providing a written post-incident review after major outages, we also now host these retrospective conversations.
You're about to watch a recording of a live stream where we invited impacted customers through Azure Service Health to join our panel of experts in a live Q&A.
We had a conversation about reliability as a shared responsibility. So this includes our learnings at Microsoft, as well as guidance for customers and partners to be more resilient.
We hope you enjoy the conversation that follows. Back on the 21st of July, we had a SQL incident that impacted the West Europe region. From reading the PIR, we mentioned that human error played a significant role here. Obviously, humans are fallible, which is why we look to de-risk our systems wherever possible from human error. So Peter Carlin, could you please walk us through what happened there?
Thanks, Sami. I'm joined today by Joe Ponce Galindo, who's the owner of the SQL connectivity stack. So we'll be walking you through the cause and the factors that contributed to this incident. I want to start off by saying something about human error. In my view, in the end, all of our incidents are caused by human error, whether it's a failure to imagine what could possibly go wrong or not building a system to be resilient enough. However, this incident is in particular directly caused by human error in that an operator working on the system took an action that had the unintended consequence of causing significant availability issues in the West Europe region. So I'd like to walk through what caused that and also what we're doing to repair and understand how we can reduce the occurrence of these kinds of incidents. Before I get there, I want to start by talking a little bit about the impact of the incident. I think that's always important to understand and focus on. So we have a nice little availability graph here showing what happened. And as you can see, over the course of almost 6 hours total, there was a significant reduction at points down to all traffic to the West Europe region for SQL database was failing. In total, over 40,000 customer subscriptions and more than 580,000 databases were unavailable during this period. And that's only the direct impact. There's indirect impact. Many of those databases are used by thousands of millions of people. So all told, probably tens of millions of people were impacted by this outage. So that's a very sobering thing to think about, and something that we obviously, as Dave was saying, definitely apologize for the failing to meet the standards that we know our customers expect. I want to talk a little bit, okay, why did this happen? So to do that, I want to start by showing a diagram of how the connectivity to Azure SQL Database works, to give a sort of context for this incident. We have a number, millions of VMs that support SQL databases. And when a connection comes in, it's routed to which VM is hosting that particular database at that particular point in time, but what we call our connectivity or control ring stack. That stack's basic job is to translate, I'm looking for this logical server, I'm seeking to log into this logical server, to which VM is currently hosting that server. To do that, it basically has a lookup cache, and because this cache is used, or this piece of information is used literally billions of times a day, there's a multi-layers of cache, and it has to be kept up to date with changes. People might drop or create resources. Those resources might get moved around due to all sorts of reasons, and that cache has to be updated in real time as well as read many times. So to do that, we have, again, a multi-layer cache, starting off with a persistent version of that cache in these what we call alias databases. There are many of these alias databases per region in West Europe, which is a large region, and those are distributed across several availability zones. In addition, there's a set of gateway processes, we call them, and there's, again, many of these, and they have an in-memory cache of that information as well, so that when a request comes in, they can quickly find out, okay, right now I need to route it to this particular place. So this all looks great. It's a very resilient system. It's distributed across availability sets. Failure of an individual gateway, an individual alias cache, an individual router, anything of these things can fail and the system keeps working. So what happened? Well, in this case, what it's not resilient to is someone coming in and unintentionally deleting all the alias DBs. And that occurred because the person was attempting to do maintenance on those databases. And let me actually bring up a little list of the contributing factors to this to help explain this. But basically, as with any cache, it sometimes has errors in maintaining its proper state, and we find cases where that cache has an incorrect entry. So usually it's automatically maintained, obviously, but sometimes errors happen, and we need to go address those and fix them. So in this case, an engineer was attempting to, in essence, clean up the cache and remove a particular entry from the cache. Unfortunately, they used the wrong command. So the correct command to remove one instance from the cache is remove SQL alias. But instead, the person issued the command remove SQL alias cache, which removed the entire cache. Now, you may ask, why would we possibly have a command to do this? Like, why would you want to do that on purpose? It turns out that when we're decommissioning a cluster or a set of resources, which we need to do, hardware ages, data centers change, we need to move things around, we do need to delete these caches, and that's an automated system to do that. But sometimes, again, there needs to be human intervention to make sure it happens properly. So that's why we have that operator command. So it's kind of interesting actually that that's the basic reason why this occurred. And then if we start to think about as this played out, the initial impact was actually very low because, as I said, there's multiple of these caches and they're resilient and traffic is automatically routed from one to the other if something goes wrong. So as these caches were deleted, at first there was no impact. But eventually enough caches were deleted that there was started to be not enough throughput possible in the region, and eventually all of them were deleted, at which point there was no traffic possible in the region. So at this point, I want to hand it over to Joe to talk a little bit about the mitigation and what we did to recover from this, because there's interesting learnings as well from that.
Thank you, Peter. So yeah, the mitigation was a multi-step process. Once we figured out that the issue was being caused by these caches being deleted, we were able to identify the process, and we were able to put a stop into that purging of the cache that was going on. Once we were able to put a stop into the caches, we were able to put them back online. Here, I would like to pause a little bit to give more detail on how this deletion of the SQL alias caches works. So the deletion is actually a multi-step process. So it's not like a blanket drop database command. It's actually a workflow that needs to be very careful of maintaining a certain state with our control plane. In fact, the deletion of the physical data or the physical database is the very last step into the process. So we were able to pause this deletion that goes record by record, and that helped us to, once this was paused, to put it back online. To put it back online, we had to reconnect the gateways that were shown in the diagram. The gateways have essentially a connection string knowledge about where these SQL alias databases are in the cluster. So we were able to reveal that knowledge that got deleted as part of the multi-step workflow of cache deletion. And as soon as we were able to put that knowledge back into the gateways reconnected and started to service logins. Of course, as any outage that happens at this level, we originally, once we started to bring some caches online, some of the gateways didn't react properly to this update of connection string information, and they had to be restarted in order to bring back the full availability in the region. Lastly, we had to do a large reconcile process. So given this was a multi-hour outage, there were many entries in the SQL alias cache that became stale to what the actual source of truth, which is maintained in our control plane separately. So they diverged, and we had to put we had to manually work on some scripts figuring out what were the multiple cases that could lead to these stale caches and divergence of the data. And once we corrected and reconciled the caches, then the full availability on the region came back. There were some painful secondary effects, unfortunately, during this incident. And those also secondary effects brought us very interesting learnings that are helping us to build even more resilient systems. One of those secondary effects that is worth calling out is that at the same time as this incident happened, we also had a internal telemetry outage that impacted this region, and coincidentally at the same time. Once we looked deeper into this telemetry issue, what happened actually is that we got the telemetry system got overwhelmed with increased number of requests that were coming from our Azure Support Center or Azure Support portal. So every time customers open support cases in the Azure portal, we kick off a large number of automation in order to try to figure out what could be the potential cause and be able to provide a quick support guidance in the portal if we are actually able to. And given the very large impact we observed during this incident, we ended up, the system on telemetry system ended up being overwhelmed. And this had, two consequences. The first one is that the engineering team that was working during this incident was partially flying blind, and we were not able to find as quickly as we would like to what was the real cause of this problem. So that was one of the key contributing factors to a very long impact and really mitigation effort. It took us a while to figure that out. The second problem that was caused by this telemetry outage is that we have this auto failover feature in SQL database, and that auto failover feature ends up depending on our telemetry systems in order to find out which customers are ready to be, to actually apply the auto failover feature. This ended up impacting the auto failover, and by the time we figured out how to work around the telemetry dependency on the auto failover playbook, well, the recovery was already in progress by that time. It's worth noting here that the manual failover was not impacted during this incident. And well, lastly, about there are many learnings and service repairs that we are conducting as part of this incident. Obviously, we are adding a resiliency and safety checks into these cache deletion operations. During that same day, we blocked the execution of this command worldwide to avoid any more mistakes, and then we have implemented the safety checks in order to prevent these commands to be executed on live rings. We have also implemented stricter throttling telemetry systems precisely in the telemetry store in order to avoid this overwhelm of one source of telemetry queries, in this case, the support center, to impact other critical workflows inside the system. And we have improved the playbook of automatic failover in order to remove this single dependency on the telemetry store and have alternative or additional sources of information when to be ready to react in precisely disasters. So with that, I would like to, on behalf of the Azure SQL DB team and the Azure system, to apologize to all our customers for the impact that this issue might have caused. Thank you.
And Scott, any follow-up questions for the team?
Yeah, I guess the question I had was, on the auto failover for this incident, what did we learn from, that aspect? And you could talk a little bit more in terms of automatic versus manual failover. And then maybe also, I know customers can also configure their own active geo-replication, and maybe in this incident would have been able to recover by performing a forced failover. I was wondering if you could maybe talk about, again, what do we do automatically, and then what should customers do to also be able to take action in incidents like this in the future?
Yeah, I'll take that question. Thanks, Scott. So Azure SQL Database has a feature called active geo-replication, which propagates transactions from one region to another region in near real time. So it's always less than 5 seconds behind the primary region. And we have a capability on top of that called auto failover, where a customer can sign up and say, anytime an incident occurs in the source region that lasts longer than some amount of time, please automatically fail my system over to this other region. And this was what Joe was talking about the auto failover system is set up to identify the databases that are signed up for that feature, look at how much time it's been, et cetera, and fail over the customers. In this case, the system did not work for the reasons Joe outlined, but in general, this is the way in which customers can be more resilient to region-wide issues. In addition, we have, as Dave was talking about, in many regions and for many pieces of the Azure platform, multiple availability zones. And we work really hard to make sure that as much as possible, fault domains are contained only within availability zone. So there's no single point of failure that can hit multiple availability zones. West Europe is a region with multiple availability zones, and as I talked about, for instance, our gateways and those caches and the VMs are distributed across multiple availability zones so that one failure in one case should not propagate. In this case, of course, this was an incident that crossed multiple availability zones because we went in and deleted the caches in those different availability zones. However, fortunately, it was not a cross-region outage because and no other regions were affected. So a customer with active geo-replication would have been able, had the system been working properly, to fail over to another region.
Super, Peter. I like what you said earlier about every issue is human error because we fail to imagine it and so on. But I am interested and have a couple of questions from customers about what changes are you making to SQL to prevent humans from doing this kind of thing again in the future?
Yep, I think that's a really good question, and this is a really interesting incident for those sort of human factors. So the first thing is the easiest, most obvious thing is we've renamed the command. So as you can see, the commands are very similar, and in fact, it does turn out that we have sort of autocomplete on the command thing, so it's very easy to accidentally mistype and get the wrong command. So we've renamed them. The second thing is that all these commands need to be sort of smart. They need to be thinking about, oh, it's entirely possible that this will be executed at the wrong time, and they need to do checks. And there are checks built into these commands. For instance, for this command, is the region or is this cache really not in use? Because it's intended to be used in a decom scenario. And obviously those checks were not sufficient and incomplete and actually thought it was okay to proceed. So we've boosted up those checks. Another aspect here that's really important is operators are human, and as much as possible we want to make sure that it's easy to do the right thing. And that means as much as possible when something happens, whether it's something like in this case where we were responding to another issue, right? Another issue had occurred which caused one particular database cache entry to be incorrect, that we have what we call them TSGs, but basically clear guidelines as to exactly what to do. And the request is, and what we want people to do is follow the TSG. And that can often, that's easy when it's easy. When something goes wrong, people tend to panic, right? And that's when things most often happen badly. And so to some extent, it's to give people confidence and really encourage and build in place systems that create a culture of always following the TSG, even if, oh, maybe this is wrong, or then stop, ask questions. Another piece of that is what we call for historical reasons, it's called a CAB, Change Advisory Board, to look at each change that's going to be made to production and make sure there's at least 2 pairs of eyes on it at all to say, yes, this is the right thing to do. So in this case, looking at that particular CAB to say, okay, this is the command, is that the right command to use in this instance? Now, obviously, not all systems are perfect, and in this case, the CAB even said, do the right thing, but the operator ended up doing unintentionally issuing the wrong command. So, those are all systems that we try and put in place to put as many layers of defense in depth, knowing that people will make mistakes. And if you do something a million times, at least one of those something is going to go wrong. So we want to have the defense in depth, not just in our systems, but in how we interact with those systems.
Great, thank you. And I also want to open it up to the broader panel, and maybe Dave, especially, if you have any additional thoughts around human error, or if some of these safe deployment practices that applied in the situation you discussed would have applied here as well.
So safe deployment probably wouldn't have been actionable in this particular case because it was an operator-initiated change. In the networking space, though, we do have situations very similar to what Peter was describing for SQL, where we need a human operator to go do something. That might be turning up new circuits, new fiber to new connectivity, or migrating from one set of equipment to a new set of equipment. And so like the SQL team, we have what we call methods of procedures. This is an explicit written step. Nobody can, well, one, there are many authentication principles. Nobody can just walk in and log into the production equipment and start making changes. There first has to be a method of procedure, a written document that's gone through and reviewed by a change advisory board. Then they use what we call JIT, just-in-time elevation of privilege, to get access to say, I'm going to access to production to make this set of changes here, and then follow that method of procedure. And like Peter was saying, one of the things we've been doing is actually even taking that method of procedure and essentially automating it. So now our engineers, rather than writing a text document saying these are the steps we're going to do, they're writing essentially a list of instructions, which can then be formally validated. We actually have a simulated or emulated version of our network that just lives in the cloud. It's an emulation of each of our network devices. And so we'll run that series of changes on this digital twin of our real network to make sure it works correctly there. And then we'll have that same automatic execution system run the method of procedure against the production network. So these are the kinds of investments we're making to make sure that humans can't accidentally fumble finger things.
Thank you for watching this Azure Incident Retrospective.
At the scale of which our cloud operates at, incidents are inevitable.
Just as Microsoft is always learning and improving, we hope our customers and partners can learn from these too, and provide a lot of reliability guidance through the Azure well-architected framework.
To ensure that you get posted incident reviews after an outage and invites to join these live stream Q&A sessions, please ensure that you have Azure Service Health Alerts set up.
We really focused on being as transparent as possible and showing up and being accountable after these major incidents.
Whether it's an outage, a security, or a privacy event, Microsoft is investing heavily in these events to ensure that we earn, maintain, and at times rebuild your trust. Thanks for joining us. Thanks.